So hi, I'm from the Digital Innovation Lab. What the heck is that? Other things I haven't heard of. I'm from main campus, the boring part on that side. And our lab primarily deals with digital humanities. And as part of our sort of digital humanities umbrella, we carve out a slice of that to try and step into 3D data, 3D scanning, some rudimentary VR. We don't have the budget yet to play in AR, but we're trying to get there, and we're trying to help our humanities faculty and graduate students primarily, although occasionally we get undergrads involved as well, to try and embrace technology in their humanities research in new and interesting ways, or at least if we can. Make sure this is going to increment correctly. I just talked about that. So AR/VR is about, winds up being about 10% of sort of what we're doing. Brian happened to swing by a couple weeks ago, and I was sort of chatting about what we've done this year, and he was like, hey, would you mind sharing this with everybody? And I was like, really? People want to know this? So I'm here to sort of briefly go over sort of what we're doing. So we've had a couple different initiatives. We don't have a whole lot of hardware, but I just thought I'd sort of point out this is what we've got. We've got a couple machines, and we've got a Vive ProRig, and we've got this IronScan Pro Plus handheld photogrammetic scanner that can do some pretty interesting things. It does have a turntable, but can also become handheld and allows us to do about 3 meters in every axis, so we can scan some relatively large things. One of our early projects was with some historical artifacts that were, roughly the size of a cafeteria tray, big enough that a traditional sort of fixed scanner couldn't quite handle it. We had some end-of-year money that needed to get spent down, so it was like, hey, let's get a scanner. So that's sort of the initial sort of proof of concept project. And what we've been doing recently, we're working with Joel Hudley over in Geological Sciences. And it's like, wait a minute, that's sciences, we're digital humanities. We have a very loose definition of digital humanities, and that we're all humans that are doing the research, so it's sort of humanistic. And mostly we're just collaboration junkies. We like to work with people doing interesting things. This particular project, they brought a series of fossils over to be scanned, and their workflow involved, once they had these scans, they would analyze the growth rings and then be able to measure not only surface measurements, which they could do with the actual artifact, but to do sectional measurements, which traditionally they have to destroy the fossil to do that. So this was sort of a brand new workflow for them to be able to scan these and then be able to take all their measurements digitally without harming the sample. And they're particularly thrilled. They've already got a backlog of more things they want to come and do this with. And it's proving so far to be exactly what they expected it to be. So it slows them down a little bit, but they don't have to get the wet saw out. They're not cutting rocks up. So they can potentially go back and reanalyze. So it enables them to have a sustainable workflow, if you will, with these somewhat rare fossil artifacts. Related to that, like I said, Geological Sciences got our number this year. So we were working with Michelle Haskin, and this is sort of directly pedagogical. What geology has done in the past is they literally have a box of rocks, and they are specific mineral samples, and they bring them into classes and allow people to manipulate them and handle them and feel them and touch them and all this kind of good stuff. And it's a very corporeal human experience. The challenge is throughput. You only have one box of rocks. And some of these rocks are relatively rare. They have lunar rocks. They have all kinds of fun things that you can't necessarily find everywhere. So the point of this project is we're scanning these at incredibly high resolution. The mesh file alone is over a gig in its raw form. So we're scanning these at incredibly high resolution. And then we're dumbing them down so we can share them on the web. But we have these very, very high-res scans. And I've showed you here that it's kind of hard to see, but this actually has a fossil in it. It's a plant fossil impressed into the rock. And I can pull up the meshes here on my machine if you want to see them after. But in conjunction with traditional photography and some digital microscopy, which we're hosting through GigaPan, where we have these amazingly large microscopic plates that we can digitally provide, which will allow us through a web interface that we're also building for them to have a 3D model, to have traditional photographic images of the rock sample, as well as these digital microscopy images of the sample, all of which can be delivered virtually. So now all of a sudden they have the option now to offer classes online that they could only really offer in person. So it's sort of trying to detach this particular pedagogical resource of the box of rocks and try and make a virtual box of rocks. And they're pretty tickled so far, although when I realized how big the data was going to be, we've had a couple interesting conversations. So those are sort of the two things. And then we've also been supporting Dr. Lucia Bonatti in Romance Studies, which is sort of Romance languages. If you've never seen Romance Studies, you're like, you can study Romance? What? It's more linguistic. But we were using Wanda VR and 360 video for a class project. So we had roughly 26, 27 undergrads building Wanda VR experiences through the course of the semester. We were able to support that. And our support for that particular project involved us finding some money to pay a grad student to basically hang out and be sort of an on-site assistant for that particular class for this semester. Unfortunately, they haven't published the projects. They kept them local, and I don't have one to show you. But it's sort of interesting. And bringing Wanda VR into an undergraduate classroom, we learned a lot. We found the holes in some of the Wanda documentation, but by and large, they were successful. So that was pretty fun. And this is probably the money shot here, considering what's coming up after me, which is going to be much more interesting and sexier than this. So we have developed at the DIL a data visualization plugin for WordPress called Prospect. And it's available to the world. It's open source, prospect.unc.edu. And it can do relatively simple relational databases. Obviously, when you're using a web server to do data visualization, there's a round peg square hole issue. Our largest project right now that's actually functioning is about 130,000 data points, which in the realm of medical data is nothing. In the realm of humanities data is huge. So we know that there's some, we're never going to be the next R, but for a lot of humanists that don't necessarily have budget or computer scientists in the team, this particular package allows them without too much overhead to come into the world of data visualization. We worked with the computer science 523 class to develop a prototype to bring 3D visualizations into our WordPress web plugin. So these are some screen caps, and what this effectively is a relatively standard network graph that's been then extruded through time and allows us to look at a systematic view of these relatively complex networks. This particular data set is genealogical. So we're looking at a particular family tree from 1760 through about 1910. One of the major families in North Carolina, this was the Battle family, as in Battle Hall, and you'll see that name a lot around this area. So each node is an individual, and they have a lifespan, and then we have different types of relationships between them as far as marriages. We have parent-child relationships, and we also have slave and owner relationships marked out there, because there are a few bastard children where we have documentation that this was the child of a domestic or whatever. So, and unfortunately, my prototype is not working this morning. because it's a prototype. So unfortunately, we have to deal with only screenshots. But this is 3DS or 3D. I forget the correct acronym. D3, and it is HTML5 compliant. So you can actually access this through the web. So we're kind of excited about that. It's still roughly a year-ish away before it's actually going to come out. We've got a lot of massaging to do, but we have a working alpha, and that's pretty cool. And I'm guessing that's probably going to segue into what's coming next, which is going to be far more interesting. So that's my 15 minutes of fame.
All right.
Thank you.
Do you have any questions?
Yeah.
So have you, with the fossil scanning, have you actually done comparisons between your results for measuring virtually and field measurement?
I haven't, but the faculty member has, and they're satisfied that it's within their margin of error, that it's basically equivalent. So, yeah.
I'm really fascinated by the last slide there, which is, I've never seen someone else do this, which is time is the up and down dimension.
Yes, time is the z-axis.
And so it's almost like a whole series of slices of time, and any one of those, you can get nodes and connections between them. But this is a way of viewing it all up and down.
Yes.
In particular, I want to talk about 3D data visualization. I think this would be really great to get, especially multiple people who could walk around the data, really explore it, like click in and say, what is this one? What is this relationship? You know.
And with HTML5, we should be able to put this into a head mount without much hassle at all. And we literally already have it on the web, and that technology exists. So we think we're only one step away from being able to put this in HMD. And the way this interface works, you have an intersectional plane that you can control over here on the right-hand side, which will eventually give you a 2D overhead representation of that particular slice in time. So you'll be able to see the volumetric view, move a plane in the volumetric, and then see in the 2D representation of what you're going to see in that plane. So hopefully it'll give you the ability to analyze through sort of this temporal matrix of these human networks. And I really wish I could demo it, because then I could show you and tell you about it, but it's not working. So yeah.
Storage an issue for the geological sample?
Not in my rig at the moment. I've got 4 terabytes. So yeah, it's not proving a problem. They weren't quite ready to, I was going to give them a handoff and sort of give them all of their, the full boat, and the raw scans are huge, and we're probably not going to archive those. But yeah, when I was sort of approaching them, I said, oh, by the way, it's, right now the project's sitting at about 85 terabytes. And they sort of went, what? So yeah, we're figuring that out. But yes, the intention is we're going to have, geological sciences will have an archive of the high-res scans, not necessarily the original, but the highest res mesh output we could do. And they'll keep that sort of in their back pocket for future proofing, and they may realize that they can up-res and put something online that's a little bit bigger. And then we're dumbing them down to in the vicinity of 50 meg or so that we can put them online. But yeah, this particular scanner has max res is, I believe it's 0.8 of a millimeter per slice, and they were doing, most of these samples are small enough, they're doing it on the table, so they're doing about 64, I think, segments in the rotation, so they can see. Let's see if I can show you. You can zoom into these and get quite a bit of resolution as far as any sort of topographical issues, which is exactly what they want their students to be able to see. So if it's a striated particular sample, they want to be able to show, you can see the layers and try and get as close to being able to run your fingernail across it like you could in real life, virtually. Anything else?
One of the things that you brought up that I think is interesting is UNC now has a new vice provost for digital and online lifelong learning, I guess. And so that's vice provost level. That's pretty high up. Yep. And the way I look at it, if you read Clayton Christensen or the future of the universities and such, there's only so many 18 to 22-year-olds who can physically fit on one spot, right? But the number of people who can fit online and around their own schedules of any age, it is functionally billions of people. It could be any number of people. And so it would be very easy to conceive of the university having 10 times as many students if 9/10 of them are online. And so the question that you are taking this box of rocks and then you're turning it into a digital object that someone who is anywhere, anytime, can look at. Suddenly, I think that I don't think a lot of people are necessarily yet tying together this augmented virtual reality work with our online work, but I think it's just destined to collide.
Yeah, I think it's just a matter of time. As the technology evolves, it's going to be easier and easier. We're going to go from keyhole experiences to immersive experiences through distributed experiences. It's simply a matter of time. I mean, I came here from Carnegie Mellon, where I was doing entertainment technology and doing a lot of VR work. This has been 13, 14 years ago. And where the hardware has come in that period of time is just mind blowing. We were working on systems that were, just for the receiver, it was, $35,000, and you had to have 3 bespoke computers to run it and custom code. And it was just a royal pain in the butt to try and author for head mount 15 years ago. You could do it, but man, it was painful. And nowadays you can design in an engine and then you can port it to 4 or 5 different pieces of hardware with a button push. I mean, that's pure fantasy from where we were 15 years ago. So imagine what 10 more is going to give us. I think it's just a matter of time.
Any last question?
Let's get to the fun, cool stuff.
All right, thanks, man.
All right.
Should be good to go. Is it recording that side of the screen? Should be.
Yeah.
So I'll tell you,